Hello class, today we're going to go ahead and do section 7.5 part 2. So we've already done the first half of the notes. Now we're going to pick up with adding and subtracting radicals. Okay, so you add radicals in the same manner as adding monomials. You can only add like terms or like radicals. Okay, so if what is underneath the radical is not the same, you cannot add them. Okay, so here is an example. Okay, if I have 2 cubed root of 3a plus 6 cubed root of 3a, since they have the same index and the same radical, okay, you can go ahead and add them since this piece is exactly the same. So you would just say, well, 2 plus 6 is 8, so it is really 8 cubed root of 3a. If you look at the other example, these are not alike, and so you cannot add them. This is the cubed root of 3a, and that is different than the cubed root of a. So you cannot combine them, so you would leave them separate. Same thing here. This is the cubed root of 3a. This is the square root of 3a. So they're not the same, so you cannot combine them. They must be exactly the same in order to combine them. So let's look at an example. Number 11. I see this and I think, oh, I can't add any of them because none of them are the same, but you can simplify. I would say, well, what's my perfect square in 12? 4 times 3. Okay. And here's a little trick that I use. I know that when I take the square root of 4, it is 2, so I'm going to have 2 times 2 square root of 3. So what I want to do if I want to combine these is I want to be able to get square root of 3's underneath it. So I want to think, well, 3 times what gives you that value? So for the next one, I would say, well, 3 times what gives you 27? 9 times 3, and 9 is a perfect square. Plus, next one, 48, I would say, well, 3 times what gives you 48? So you take 48 divided by 3, it's 16. And 16 is a perfect square. So that's kind of a nice little trick you can do. So I would have minus 3, the square root of 9 is 3, and then times the square root of 3, plus 2, square root of 16 is 4, square root of 3. And I'm just going to go ahead and combine them, or multiply. So I have 2 times 2 is 4, square root of 3, minus 9, square root of 3, plus 8, square root of 3. Now, since they are all the same radical, you can go ahead and add them and subtract it. So we'd have 4 minus 9, okay, which gives us negative 5. Negative 5 plus 8 is 3, so it's 3, square root of 3. This is exactly the same type of idea as this. These are like terms, so I can combine them. They have to be like terms. 4 minus 9 is negative 5. Negative 5 plus 8, once again, will give me 3x. So just to keep that in mind, they have to be the same. Number 12. All right. So I just start looking at the first one. Well, my perfect square in 8 is 4. So it's going to be 4 times 2. Okay, well, when I take the square root of 4, I'm going to only have 2 left under the radical. So I would say to myself, well, 2 times what gives you 32? 16 times 2 minus 4. 2 times what gives me 18? 9 times 2. Square root of 4 is 2, so I would have 3 times 2 square root of 2 plus 5 times square root of 16 is 4, square root of 2, minus 4 square root of 9 is 3, square root of 2. Now they are all the same, so I can combine them. Okay, this will be 6, 20, 12. So I would have 6 plus 20 is 26. 26 minus 12 is 14, so I would have 14 square root of 2. All right. 13, let's go ahead and look at this. Before we were just adding and subtracting. Now we have multiplying. Well, like before, in order to solve this, I need to FOIL. So when I multiply this, I would get 6 square root of 5. Then I would take this times this. So that will give me plus 3 square root of, it's going to be 5 times 3. Negative 2 square root of 3 times 2 will give me negative 4 square root of 3. And the last one, I will have negative 2 square root of 3 times 3. Okay, so I'm going to combine my like terms. This will give me 6 square root of 5 plus 3 square root of 15 minus 4 square root of 3 minus 2 times, well, this is going to be 9. The square root of 9 is 2. So it's square root of 9 is 3. So it'd be 3 times 2, which is 6. Then I will go ahead and combine my like terms. Well, if I look at it, my radicals, the first one's the square root of 5, then 15, then 3, and then we have a number. So I can't combine any of those. So there is my solution. Example 14. Okay. Same thing. We're going to FOIL. Okay, so I would have 25 square root of 3 times 3, which will give me a square root of 9. Okay. Plus 6 times 5 is 30 square root of 3. Negative 6 times 5 square root of 3 is minus 30 square root of 3. And lastly, negative 6 times 6 is minus 36. Okay, so if I simplify, the square root of 9 is 3, so I would have 25 times 3, which is 75. These will cancel, and then I would have 75 minus 36. If I do that, I get 39. Okay. One thing I want you to notice is we got a numerical value. So let's look at the original problem. Okay. You should look at this for a second, and what do you guys notice? They're exactly the same, other than one has a negative and one has a positive. Okay. So this is what we call the conjugate. Okay, they're conjugates of one another. Okay, so one thing in order to figure it out is you could think, well, think opposite of the difference of perfect squares in order to get this value a little bit quicker. So when I put it back together, okay, if you wanted to, this is just a little shortcut. Originally I had whatever this was squared, okay, minus my last value squared. And if I do this, I'll have 25 times 3 minus 36. 75 minus 36. If you don't remember this little trick, sorry, this is 39. If you don't remember this little trick, that is fine. It's just something I'm showing you. But we are going to be using the conjugate in the next problem. So in 15, we all know that it is not proper to have a radical in the denominator. So in order to get a radical out of the denominator, when there is addition or subtraction also in the denominator, you need to multiply by the conjugate. Okay, well, the conjugate of my denominator is just going to be the opposite. Well, this is plus, so it's going to be 5 minus the square root of 3. Okay, so I'm going to go ahead, FOIL the numerator. So I would have 5 minus square root of 3 minus 5 square root of 3 plus square root of 3 times square root of 3 will be square root of 9 all over. And this is where you can FOIL all the way if you want, or you can, like I said, think how would I put back difference of perfect squares. I would just take the front number and square it, so it would be 5 squared, okay, minus the second number squared. If I combine my like terms from above, this is really 3. 5 plus 3 is 8. Negative square root of 3 minus 5 square root of 3, it's really negative 1, so it would be negative 6 square root of 3 all over 25 minus 3. Okay, so I would then simplify again. So I have 8 minus 6 square root of 3 all over 22. And then there's one more way to simplify just a little bit. If you notice in the numerator, they're both divisible by 2, so I'm going to factor out a 2. So I'd have 2, 4 minus 3 square root of 3 all over 22. The 2 over the 22 will simplify to 11. So my most simplified answer for this problem would be 4 minus 3 square root of 3 over 11. Number 16, same idea. I have a radical in the denominator, and since there's addition, I need to go ahead and multiply by the conjugate. So it's going to be 6 minus square root of 5. Okay. I'm going to FOIL on the numerator. to be plus 2 times square root of 25 all over. And I'm going to FOIL the denominator this time, just so that in case you didn't catch how to do the other trick, you can see it. So I would have 36, if you don't understand the trick, I guess, minus 6 square root of 5. So this would really be 5, so it would be 2 times 5, which is 10. So 18 plus 10 will give you 28, minus negative 3 radical 5, minus 12 radical 5 is minus 15 square root of 5, all over. These will cancel, and this is 5. So 36 minus 5 is 31. Can I factor anything out of the numerator that will cancel with the denominator? No, I cannot in this case. So there is my simplified form. All right, example 7 says find the perimeter and area. Okay, so we need to find both. So let's start with the perimeter. Remember, the perimeter is just adding up all the sides. So I'm going to go ahead and do that. But one thing I would like for you to notice is, if I'm adding them up, how many sides are there like this? There's 2. So my perimeter, to kind of speed it up, I'm just going to take 2 times 3 plus 6 square root of 2, plus my other side. Once again, there's 2 square roots of 8, so 2 square root of 8. I distribute the 2. And I'm going to start simplifying, because in my square root of 8, there's 4. Square root of 4 is 2. 2 times 4 will be plus 4 square root of 2. And my last step will be to combine my like terms. Okay, so 6 plus 16 square root of 2. That will represent my perimeter, and that will be labeled in yards. So the perimeter is equal to 6 plus 16 square root of 2. The other one I need to do is my area. Remember, area of a rectangle is just length times width, so it's going to be square root of 8 times 3 plus 6 square root of 2. I would distribute, so that will give me 3 square root of 8 plus 6 square root of, 8 times 2 is 16. And I know the square root of 16 is 4, so I have 3 square root of 8, and then 6 times 4 is 24, so plus 24. And I would label this one. I would label this in yards squared, but am I done all the way? Because I would notice I still have a square root of 8. And in my square root of 8 is a perfect square, 4. And the square root of 4 is 2. So I would have 3 times 2, which is 6 square root of 2 plus 24. So now it is, my area is simplified all the way down. So make sure when you get done, you double check that. And it is yards squared. There's my area. And one last problem, number 18. It says find the hypotenuse of a right triangle with legs 2ab squared and 6ab squared. So here's my right triangle. It says 2 legs, so I'm just going to say this is 2ab squared, and my other leg is 6ab squared, and I need to find the hypotenuse. Well, I'm just going to label that x. We know that in order to find the hypotenuse, if I have 2 sides, I can use the Pythagorean theorem. It's going to be 2ab squared plus 6ab squared, ab squared, and all of that squared is equal to x squared. So I'm going to simplify, square each piece here. So it would be 4a squared b squared plus 36a squared b to the 4th is equal to x squared. I would combine like terms if possible. I made a mistake. Go back and really quick. I forgot to label. It's 2ab squared here, so add that on. My bad. Excuse me. So I have 2 times 2, which is 4. So I can combine my like terms. 4a squared b to the 4th plus 36a squared b to the 4th will give me 40a squared b to the 4th is equal to x squared. Now, in order to get my x squared by itself, I would do the square root. One thing to remember when we do square root is we have 2 answers. okay? But in this case, we do not want the negative. We only want the positive because it's the side length of a triangle. Can't have negative side length. So I would have the square root, and sorry, this should have been 40. So it's the square root of 40 a squared b to the 4th. And so I would simplify. Well, 40, I know, I can read it as 4 times 10, a squared b to the 4th. The square root of 4 is 2. The square root of 10, we're going to leave underneath there. Square root of a squared would just be a. The square root of b to the 4th. 4 divided by 2 is 2, so b squared. So we should have 2ab squared square root of 10. That would be our hypotenuse. So there is our hypotenuse. So please make sure if you have any questions, you write them down. Ask me tomorrow in class. Otherwise, you go ahead and have a great day. I will see you later.